Hi, folks. Welcome to our 4.6 part 3. And so in this video, we're going to talk about what we do when we have situations for exponential equations where we have to factor in order to solve our question. Okay, now this is a pretty common sort of situation in math where you're working on this kind of complicated problem. And it all boils down to it's actually a secret hidden quadratic function. Okay. And so this is why I make such a big deal out of factoring, because without factoring, it's actually really hard to figure out how to solve some of these more complicated problems, right? So you're layering factoring if you don't feel good about it with some harder stuff, and then it just becomes all kind of hard and overwhelming. All right, but we're going to take this one step by step. All right, but if we take a look at example 8 at the top of the screen and example 9 at the bottom, we kind of see that they're sort of similar in structure. But we're actually going to start with example 9 on this one. Okay, so we're going to start with example 9 because I think it's a slightly more straightforward, even though there's an E in it. And then we'll come back and we'll take a look at example 8. Okay, so let's scroll down to example 9. All right. So here's how we're going to begin with this. Okay. The first thing I'm going to do is I'm going to use a strategy that I use when I am factoring or when I see something that's quadratic. Okay. And that strategy is that I want to move everything to one side and set it equal to 0. And so what I'm going to do here is I'm going to take this 56 and I'm going to move it to the other side by subtracting it. All right. And so when I do that, I end up with e to the 2x minus e to the x minus 56 equals 0. Okay. Good strategy anytime you're dealing with quadratics is to go ahead and move everything to one side, set it equal to 0. Now, it might not really look like a quadratic, so let me do a little bit of rewriting with some algebra, and let's see if we can make it look more like a quadratic. So e to the 2x can be really written as e to the x squared. Because when I have a power to another power, I end up multiplying them. Minus e to the x minus 56 equals 0. Okay. Now, in the video number 1, I mentioned something about U substitution. In general, all right, U substitution tends to be a phrase we associate with Calc 1. There's some strategies in calculus that we call U substitution, but we can use this idea of substitution pretty much everywhere. All right, so here's what I'm going to do. I'm going to pick a good color here. I'm going to take this e to the x and this e to the x, and I'm going to ask us to kind of blur our eyes for a little bit. And instead of writing e to the x, we're actually going to replace everything in the blue circles with u, the letter u. Okay, so let u equal e to the x. Okay, then here's what we're going to have. Instead of e to the x squared, now I'm going to have u squared minus, instead of e to the x, I'm going to have u. Now, I don't see any e to the x's over here, so I can keep that as negative 56. Whoops. Okay. Now, this in the blue should be looking very quadratic, right? All right, so there's a lot of ways to factor, but let me take some time to really lay it out in a way that I think is effective, right? So let's talk about that factoring by grouping. So if we're going to factor by grouping, what I like to do is think about how am I going to write this minus u, right? There's another way I could write it. I could write it like negative 2u plus 1u. I could write it as negative 8u plus 7u, lots of ways to write it, all right? The way we figure out how to write it is we set up this x, all right? And I think I talked about this in a previous video, but in case you missed that one, we're going to take the a and the c, all right? So the first coefficient, the leading coefficient, and the constant term and multiply them. So 1 times negative 56 is negative 56. Then we take the b, or the coefficient for the linear term, and we write it down here. And then we think to ourselves, I need a pair of numbers that multiplies to make negative 56 and adds to make negative 1, okay? So if we think about our multiplication table, we might remember that 8 times 7 is 56, but I need a negative 56, so one of those should be negative 8, right? Because negative 8 times 7 gives me negative 56, but negative 8 plus 7 gives us this negative 1. So I'm going to take this u squared minus u minus 56, and I'm going to write it as u squared minus 8u plus 7u minus 56 equals 0. All right. So I've taken this middle term and split it to write it this way. All right. Now I'm going to group the first 2 terms, and I'm going to clump the second 2 terms. And from each of those, I'm going to pull out the greatest common factor. So for u squared minus 8u, I can take out a u times u minus 8. And from the second clump of 2 terms with the squiggles, I can factor out a 7. So plus 7 u minus 8 equals 0. All right. Now, if you remember from the previous videos, if this and this are the same, you know you did it correctly. All right, that means we can factor this to be u plus 7 times u minus 8 equals 0. Okay. Now, when I have a product of 2 things that equal 0, this one can equal 0, and so can this one. All right, so u plus 7 equals 0, or u minus 8 is 0. And that means that u can be negative 7, or u can be 8. All right. But before we get too excited and we box off those as our answers, keep in mind that our question is given to us with x's, not with u's. So in order to answer the question, we need to find x. All right. So I'm going to switch back to the black marker. I'm going to take what we got here, and we're going to put it back into this equation. U equals e to the x. All right. So really, I have negative 7 equals e to the x, and 8 equals e to the x, right? Instead of u equals negative 7 and u equals 8, I have e to the x equals negative 7 and e to the x equals 8, all right? And now we think about, well, how do I solve a exponential equation? I got to rewrite it in log form, right? And so if I rewrite this one in log form, I'm going to get log base e of negative 7 equals x. And if I do the same thing for the other term, I'm going to get log base e of 8 equals x. All right. Now, we should remember that log base e is the same thing as ln of negative 7 equals x. And over here, ln 8 equals x. But let's think back to our graph of natural log. Okay. Our graph of natural log has a shape that kind of looks like this. And in fact, one of the important things about this is that our graph of natural log has a vertical asymptote and a restricted domain. We don't have any pictures over here, okay? So what does that mean? That means natural log of negative 7 would be like something over here, but there's no graph there. that means that this is actually what we call, in fancy terms, an extraneous solution. All right, and it is not an answer. However, if we think about natural log of 8, that means it's like, let's say this is over here somewhere, that has a value on the graph, okay? So this x equals natural log 8 is our solution, okay? And we want to leave these in our exact form. We don't want to leave them as a decimal. We'll just go ahead and leave it as an exact form, okay? So let's go ahead and get all these on the same page again. All right, so we saw maybe it could be a quadratic. We went ahead and wrote it in a quadratic form. We did our u substitution here in the blue, but then we weren't done, right? We had to go back and put it all together and check both answers to make sure that they both worked. It turns out only one of them worked, right? All right, so now let's go back and take a look at example 8. All right, we're going to take a look at example 8, which I said was a little bit trickier, not that much. A lot of the stuff will still be the same. Okay. All right, example 8. We've got 3 times 3 to the x plus 9 times 3 to the negative x equals 28. Now, what I'm going to do first, and I'll tell you why in just a little bit, I'm actually going to multiply everything here by 3 to the x. So I'm going to take 3 to the x and multiply this entire equation. Okay. Now that means I'm going to have to distribute. And what I end up with is 3 times 3x squared. So 3x and 3x is 3x squared plus 9 times 3 to the negative x times 3 to the x equals 28 times 3 to the x. Okay. Now, I think we might understand why this has the 3x squared, but I want to talk about this term for a moment, right? So when we are multiplying exponentials, it means we take the exponents and we add them, as long as they have the same base, right? So what we get here is 3 to the negative x plus x. Well, 3 to the negative x plus x is really equal to 3 to the 0, which is not 3, but 1. Okay, so what that means is we can replace this whole thing with just 1. And this allows us to write 3 to the 3x squared plus 9 equals 28 times 3 to the x. Okay. And so I'm going to bring back that light blue blob from the previous problem. And let's look at this for a moment. 3 to the x, 3 to the x. And I see this squared. So I'm going to do what I did in the last problem. I'm going to move all the terms to one side, set it equal to 0, make a u substitution, and then factor. Okay. So 3 times 3 to the x squared minus 28 times 3 to the x plus 9 equals 0. And let's change to the blue marker now. Let u equal 3 to the x this time. All right, then we have 3 times, 3u squared minus 28u plus 9 equals 0. Right? And we're going to factor, just like we did last time. I want to think about how I can write this middle term in a creative way so that I can group and then factor from there. So a times c, 3 times 9 is 27. B is negative 28. So I need numbers that multiply to make 27, but add to make negative 28. Sort of a weird one, but 27 times 1 is 27. But they don't add to make negative 28. But check that out. Negative 27 times negative 1 is 27. But negative 27 plus negative 1 is negative 28. So let's take our blue marker back up to the top over here. And so that means we can write this as 3u squared minus 27u minus u plus 9 equals 0. Okay. And now I'm going to go ahead and clump the first two and the second two, keeping in mind that these middle two terms were really a more creative and more useful way of writing negative 28 or negative 28u. Okay. Now, if I look for the greatest common factor here, I end up with 3u parentheses u minus 9. And if I do the same thing over here, I'm actually factoring out a negative 1. When I factor out a negative 1, I end up with u minus 9 equals 0. And it's the minus here because minus times minus makes the plus. Okay. All right. 3u minus 1, u minus 9 equals 0. I can set each of these equal to 0 and solve. 3u equals 1, u equals 1/3, or u equals 9. All right. Now, as much as we would love to say, oh, we're all done, right? This is u, but we want x. So we got to go back and we got to find x. So we have 3 to the x equals 1/3. And 3 to the x equals 9. Now these we can actually do without using the log form because these are secretly ones that have the same base. So 3 to the x is really 1/3 is 3 to the negative 1. So that means x equals negative 1, right? And then over here, same thing, 3 to the x equals 3 squared, so x equals 2, right? But again, even though this is a super long problem, before we box off both of them and say we're all done, we actually have to make sure that both answers work. And we have to make sure that when we plug them back in, we get the right answer, all right? And what we mean by that is we got to plug them back in to the original, all right? So I'll leave that up to you to check and see whether both ones are correct or not. We'll leave that question mark here, all right? But give them a check, see if they work, because if they don't both work, then they're not both answers, okay? All right, my friends, that's it for the third part of this video. In the next video, we're going to start looking at log equations, all right? So I'll see you there.